we have two polar graphs here. R is equal to 3 sine theta and R is equal to 3 cosine theta. What we want to do is find this area shaded in blue. That's kind of the overlap by these two, the overlap of these two circles. So I encourage you to pause the video and give it a go. All right, so I assume you've tried. And what's interesting here is we're clearly bounded by two different polar graphs. And it looks like they intersect right over here. If we eyeball it, it looks like they're intersecting at when theta is equal to pi over 4. And we can verify that. Cosine of pi over 4 is the same thing as sine of pi over 4. So it is indeed the case that these two things are going to be equal to each other. Their point of intersection happens at theta is equal to pi over 4. And if that wasn't as obvious, you would set these two equal to each other and figure out the thetas where this actually happened. But here it jumps out at you a little bit more. So this is theta is equal to pi over 4. And so the key is to realize is that for theta being between 0 and pi over 4, we're bounded by the red circle. We're bounded by 3r is equal to 3 sine theta. And then as we go from pi over 4 to pi over 2, we're bounded by the black circle. We're bounded by r is equal to 3 cosine theta. So we could just break up our area into those two regions. So this first area right over here, we already know is going to be 1/2 times the definite integral from 0 to pi over 4, 0 to pi over 4 of, what are we bounded by? 3 sine of theta, 3 sine of theta, and we're going to square that thing, d theta. That's the orange region. And then this, I guess you could say this blue region right over here is going to be 1/2 times the definite integral. And now we're going to go from pi over 4 to pi over 2 of 3 cosine theta squared d theta. That's this region right over here. Now, one thing that might jump out at you is that they're going to be the same area. That these two circles, they are, I guess you could say, symmetric around this line. Theta is equal to pi over 4. So these are going to be the same areas. So one thing that we could do is just solve for one of these and then double it. And we will get the total region that we care about. So the total area, and you can verify that for yourself if you like. But I'm just going to say that the total area, I'm just going to double this right over here. So the total area, if I just double this, just the orange expression, I'm going to get the definite integral from 0 to pi over 4 of, let's see, of 9, 3 squared is 9, sine squared theta d theta. And you could evaluate this by hand. You could evaluate this calculator. Let's evaluate this analytically. So sine squared theta is the same thing as 1/2 times 1 minus 1/2 times 1 minus cosine of 2 theta. That's a trigonometric identity that we've seen a lot in trigonometry class. Actually, let me just write it up here. So sine squared theta is equal to 1/2 times 1 minus cosine of 2 theta. So if we replace this with this, it's going to be equal to, let's take the 1/2 out. So we're going to get 9/2 times the definite integral from 0 to pi over 4 of 1 minus cosine 2 theta d theta. And so this is going to be equal to 9/2. Antiderivative of 1 is theta. And let's see, cosine 2 theta, it's going to be negative sine of 2 theta. Did I do that? Negative sine of 2 theta over 2. Actually, so this is negative 1/2 sine of 2 theta. And you could do u substitution and do it like this, but this you might be able to do it in your head. And you can verify the derivative of sine of 2 theta is going to be 2 cosine of 2 theta, and then you multiply it times the negative 1/2. You multiply it times the negative 1/2, you just get a negative 1 right over there. And so then we are going to evaluate this at pi over 4 and at 0. So if you evaluate it at, well, luckily let's see, if you evaluate this thing at 0, this whole thing is going to be 0. So we really just have to evaluate it at pi over 4. So this is going to be equal to 9/2 times pi over 4 minus 1/2 sine of 2 times pi over 4 is pi over 2. Sine of pi over 2, sine of pi over 2 we already know is 1. So it is really pi over 4. So this right over here is just going to be equal to 1. So this is going to be 9/2 times, we could say pi over 4 minus 1/2, or we could say pi over 4 minus 2 over 4. So we could write it like that, or we could multiply everything out. Or we could say this is going to be equal to 9 pi minus 18 over 8. And we are done.